Okay, well, good morning. Hope everybody had a good weekend. We got a short week ahead of us because we don't come to school on Friday. So a 3-day weekend, that's always a good thing. But a few things that's going to be happening this week. Tomorrow, what's due? The homework assignment over parabolas. How's that going? Okay, going good. So okay. So I've only had one person come in with any questions, and it was on the last three, those word problems. So if you have a question, just let me know. We're actually going to have another focus activity tomorrow that's very similar to one of those questions. Maybe can help you out. But tomorrow, after we turn in the homework, we'll get the focus activity. I have an exit ticket that I want to go ahead and have you work on. It's another general form of a parabola that you're going to rewrite using completing the square into the standard form, which is what you're going to do Thursday on your what? Test. Okay, so the test Thursday is going to cover two concepts, parabolas and the binomial theorem. Okay. All right, so how many people have already started getting ready for that test? All right, hey, nice to see hands go up. But if you do have any questions, let me know. I'm here every morning. I think that's pretty much it for this week. We are going to turn in the focus activities on Wednesday. I want to go ahead and get another grade in pretty quick. There's only going to be 2 focus activities in this set. Here are the averages for the other day. So on your quiz, you ended up with a 78.1 class average. So I'd say that's still pretty good. Okay. It did beat out 8th period, but got you 3rd overall. All right, so at the end today, I'm going to pass back your quizzes, and then we can talk about any questions you might have on that. Kind of see where we'll go from there. All right. So today we are going to talk about some circles. So I'm hoping this is going to be just a review, kind of a walk down memory lane of geometry for you guys. Distance formula, midpoint formula, radius, all the associated vocabulary. Okay, well, let's go ahead and get to it. A circle is the locus, a set of all points x, y in a plane whose distance from a fixed point that we call the center in the plane is constant or equidistant. Okay, the center of a circle is the point that is the same distance from every point on the circle. An arc is a curved line that is part of the circumference of a circle. So we're talking about a portion of the circumference. A line segment within a circle that touches 2 points on the circle is a chord, as shown, while the distance around the circle is known as the circumference. And the diameter is the longest distance from one side of the circle to the other. The difference between the diameter and the chord, of course, is the diameter goes through what point? The center. Well, a chord does not. Okay. Right. Give me a few seconds in case there's anybody still writing that down or copying the circle. Okay, so these notes are going to be pretty similar to what you found on the parabolas. A little more information is going to be given. We're going to start off with some really basic problems, and then they'll get a little progressively, hopefully a little more challenging as we go through. But I don't expect today to be really difficult at all. Here's the next part. Okay, pi is an irrational number, 3.14, and it just continues randomly, equal to the circumference divided by the diameter of any circle. The distance from the center of the circle to any point on it is what we call the radius. A sector is like a slice of pie, okay, what we refer to as a wedge. All right. Now, the tangent of a circle is a line perpendicular to the radius that touches only one point on the circle. And we've heard before, if a line is tangent, there's only one point of intersection. If a line is secant, then it's going to have 2 points of intersection. But one thing that we're really going to need to know for today, if we want to go ahead and write the equation of a line that happens to be tangent to a circle, wherever that one point of intersection is, okay, that line is always perpendicular to the radius at that location. Okay, so that's going to be really useful to us in solving some of those problems today. All right. And then, of course, with arcs, you can go a little further. This resource doesn't bring them up, but you can have a minor arc. You can have a major arc. The minor arc having a measure less than 180, it only needs 2 points to identify it. Major arc, more than 180, it needs 3 points to go ahead and identify that on the circle. Okay. All this is familiar, right? Easy? Okay. Like I'm thinking, great way to start the week. Easy, easy. Okay. could say we'll almost get the whole lesson done today. Because a circle is like a hole, right? No? There you go. Well, the thing about circles, I mean, they get around. So anyway, they get around. Okay, well, one thing we're going to be using is the distance formula if we're going to try to find, say, the radius for an equation. So the square root of x2 minus x1 squared plus y2 minus y1 squared, okay, as shown in the diagram. So that's something we're already familiar with. And then we have just some basic characteristics here. An equation where the center is both at the origin and not. If it's not, we're going to refer to the center just like the vertex of a parabola. We're going to call it HK. All right, so I'll give you a chance to write that down. And then there are different ways to do this at the bottom where it talks about arc length and the area of a sector. There are different formulas available. Some of your teachers may have even taught you to set up a proportion if you're going to go ahead and find arc length or area of a sector. But I've always used these simple formulas right here. Theta measures the central angle over 360 times 2 pi r or pi r squared, depending on what you're trying to find. So basically, we're trying to find a portion of the circumference or a portion of the area. Okay. Is everybody about ready? Okay. Raphael, you okay? Get your elbow? All right. Math is dangerous. Okay, example 1. What is the equation of the circle with a center at 5, -2 and a radius 6? Okay, so a moment ago I went ahead and gave you 2 different versions where the center is either at the origin or not. Whether it is or isn't, I always go ahead and just tend to use the same form. X minus h squared plus y minus k squared is equal to the radius squared. And if it does happen to be at the origin, then h equals 0 and k equals 0. Okay. But the way we go ahead and write the equation of a circle using the center is very similar to how we would write the equation of a parabola using the vertex. What did we have to do with those values? Yeah, we took the opposite. So for example, if I've got a center at +5, -2, then what would this portion of the equation look like? X what? X minus 5 squared plus what? Y plus 2 squared is equal to 36. Because in the equation, the radius is always going to be squared. Okay, so 6 squared, there we go. All right, good, 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 good. Okay, now number 2 is a similar type question. What's the equation of the circle with a radius of 5 and the center located on the x-axis where x equals -3? So here they're just verbally describing the location. Okay, so Jasmine, what is it actually telling me the center is for this circle? I'm sorry, it's on the x-axis. So what would the actual location be, the coordinate? There you go. So I know the center is going to be at -3, 0. And we have a radius of 5. Okay, so now it's just a matter of writing out that equation that we had a moment ago. Kyle, can you help me out with that? Using -3, 0, and 5. What's the equation of the circle? All right. Well, let's start with this portion right here. Would I put x minus or x plus? Now, if we were plugging it in the general form, you could, okay? And this is why we take the opposite. So if I said x minus, and I just plugged in the negative 3 squared, what happens when we subtract the negative? Okay, so x plus 3 squared plus, how would you like to write the y portion? Okay, so he says y minus 0 squared. Okay, get rid of that little there. And what should this equal? 25. There we go. And it's just like we did with the parabolas. If a portion of it is located at 0, either on the x or the y-axis, you know, we could go ahead and say x plus 3 squared plus simply y squared is equal to 25. Okay, perfectly fine. Okay, again, it depends on your personal preference if you want to put 0 in the equation or not. Okay, example 3. And how we doing? We're moving along pretty quick. Easy, right? You guys remember in the good old days of geometry? You did not like Miss Peterson? Why? Really? Okay. I have no idea what went on, so I'm also recording, so I'm not going to say anything. So there you go. Last I heard, didn't she go to Chick-fil-A? Is she still there? Hey, if she's happy, there you go. All right, example 3. So let's see if I can maybe fill in some of the gaps here. Write the equation for the translation of x squared plus y squared equals 4 by 3 units to the right and 2 units down. Sketch the original circle and the translated circle. Find the distance between the two centers. Okay, so given this equation, okay, this is located at the origin. Okay, so that's going to be 0, 0 for the center. What's the radius? Okay, the radius is 2. Remember, in the equation, the radius is always squared. So you were probably, hopefully shown, you know, in order to graph the circle, I would just go the distance of the radius in 4 directions, like up, down, left, and right. And then you can just go ahead and connect those points right there. It's not the best circle in the world, but it gets the job done. Okay. Oh, thank you. I appreciate that. Now, we want to go ahead and translate this. Now, we're not going to dilate it, so I'm going to have the exact same circle when I finish. We're going to go 3 to the right and 2 down. So 3 to the right, 2 down, so the new center is here, but it's going to have the same radius. So 2 up, 2 left, 2 down, 2 right. There we go. So all I did was just translate the circle across my plane. Okay. So what would the equation of the new circle be? In fact, I can go ahead and just get the foundation ready. Now, we know there's no dilation, so it still has to equal 4 because we have the same radius. But what's the new center? 3, negative 2, so I should put minus 3 plus 2. There we go. So there's the equation of the new circle. Now it says find the distance between the two centers. So I can actually go ahead and use the distance formula, or because I have this one graphed, I could just go ahead and create a right triangle, which is how the difference formula is derived anyway. What would you guys prefer? You just want to use the right triangle? Okay. So basically the distance between the two represents the hypotenuse. What's the height? Okay, so I got this triangle right here. It's a bumpy triangle, but it'll do. So let's see here. The height was 2. What's the base? 3. Okay, so let's say D is the distance I'm looking for here. So the distance squared is equal to 2 squared plus 3 squared. In order to find the distance, I take the square root. So what does it look like I have here? We translated the center how far? 9 plus 4 gives me the 13. So I translated it square root of 13 units. Okay. Easy? Okay. How far did you guys go with circles? Because I'm finding that people went different things. Some people were only taught the equation of the circle. Some people were shown how to find the tangent line to a circle. Does that sound familiar? Did you guys actually find arc length and area of a sector? So that's familiar? What's that? Commissioner Reeves class? Okay, cool. All right. Well, let's see what we got here. Example 4a. Write the equation of the circle that passes through the point 6, 4 and has a center at 2, 1. Okay, well, again, if you're going to write the equation of a circle, you need the center and the what? Radius, which I don't have here. Because I am given the center, I can at least go ahead and say x minus 2 squared plus y minus 1 squared equals, we just got to figure out what the squared radius is. Okay, so how can we find that? Again, the distance formula. Okay, the distance between 2 points in the plane is going to be the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay. And it doesn't matter how we go ahead and start. Let's go from the point to the center. So the difference of the x's would be 6 minus 2 squared. The difference of the y's, 4 minus 1 squared. And I'm just going to go ahead and plug in, but let's simplify mentally. Looks like I got a 4 squared plus a 3 squared. So ultimately that would give me the square root of 25. So the distance equals the square root of 25. Hey, come on. Okay. So we can find the actual distance, which is going to be my radius, okay, which is 5. But remember in the equation, we can go ahead and leave it squared. So I'm going to go ahead and put 25 there. So in this kind of problem, it's not probably really necessary to go ahead and find the radius. We just need to know what the squared radius is going to be. Okay. Now it says write the equation of the line tangent to the circle at 6, 4. Okay, so let's say we have, the circle here with my center at 2, 1. So let's say this right here is 6, 4. Well, I want to know the equation of that line. Well, we have a point, but if I'm going to write the equation of a line, what do we need? Something really important to a line. We need the slope. Okay, so what was something that we brought up earlier that could be really useful to me? There we go. At that particular point, that line of tangency is always going to be perpendicular to the radius. Okay, so how does that help me? The negative reciprocal, there we go. So why don't we go ahead and find the slope from this point 2, 1 to the point 6, 4, and then as Aiden said, we'll go ahead and take the negative reciprocal. All right, so the slope is going to be the change in y over the change in x. All right. And it doesn't matter what direction we go. Again, why don't we just go from 6, 4 to 2, 1. So 4 minus 1 over the 6 minus 2. So it looks to me like the slope is 3/4. Okay. So what's the perpendicular slope? Negative 4/3. We change the sign and we take the reciprocal. There we go. So this line right here, I know it has to have a slope of a negative 4/3. Okay, so all I want to do is write this. Now, it doesn't say specifically what form, but let's go ahead and write this in slope-intercept form. What form is that? Yeah, y equals mx plus b. So I'll go ahead and give you guys another choice. There's 2 ways we could do this. We could either plug our values directly into the form that we want, or because we have a point and a slope, we could use point slope form and then just rewrite him. X minus x1. Okay. So what would you guys prefer to do? Would you like to use point slope or slope intercept? Jack, what do you think? He wants to use point slope. Okay. So let's say this point of tangency right here, 6, 4, that's your x1, y1. Well, we already got the slope m. So if y1 is 4, I'm going to start by saying y minus 4 equals slope m negative 4/3 times x minus 6, x minus x1. Okay. Now we just have a little bit of manipulating to do. Is everybody okay with what I've done? Okay. So somebody distribute that negative 4/3 for me. So that would be negative 4/3 x plus what? Plus 12? Now we ultimately will end up with 12, but right here we should get what? 8. There we go. There we go. And now when I go ahead and add the 4 over, that's where we're going to get the plus 12. So that should be the equation of the tangent line at 6, 4. Okay. Questions? Easy? Good old algebra and geometry? Brings back amazing memories? I guess not for Jack. Okay. All right. Well, let's go ahead and try another type of problem. It says, write the equation in standard form by completing the square. Okay, so here's the general form of a circle. Okay, so we're going to do the same thing we did last week. In fact, on Friday, that we did with the parabola. We're just working with a circle now. Okay, we're going to complete the square. The only difference is we're going to be doing it 2 times in the same problem. So the same condition is going to hold no matter what type of conic it is. Circle, ellipse, hyperbola. The leading coefficient has to be what? Has to be 1. So this one right here, we're good to go. We got a 1 on both of those, so I don't need to worry about factoring a value out. I'm going to go ahead and show you how to do that probably, if not tomorrow, then on Wednesday. Okay. But what's the one term we don't need? Yeah, that constant, the 8. So we're going to go ahead and rewrite this and move the 8 over. So x squared plus 4x plus some number. We'll leave a little bit of room. Then plus y squared minus 6y, again, plus some number, is going to equal -8. We just went ahead and subtracted him over. Okay. So let's see here. Who have I not talked to? Shayna, how do I complete the square? What do I actually do to find that value? Okay, so she says half it, so divide by 2, and then square it. That's exactly right. So I'm going to take the coefficients of those linear terms, divide them by 2, and square them. And it doesn't matter if positive or negative, your value will always come out positive because of the square. So 4 divided by 2 squared, what's that give me? 4. So if I'm going to add a 4 here, got to make sure to add a 4 to the right. Got to maintain that balance. Now the other linear coefficient, -6, divide by 2 squared, what do I get there? Thought I heard somebody say it. 9. Okay. Because 6 divided by 2, 3 squared. So I'm going to put a 9 here. That means I'm going to add a 9 on the right. See, if the coefficient was something other than 1, we would have to remember to multiply that by the coefficient, which is I'm going to show you the next day or so. Okay, so let's simplify this portion right here. These are 2 different perfect square trinomials. So we talked the other week, if I were to factor them, the group factors will be identical. So what we're going to do is condense them. In fact, can anybody tell me what does x squared plus 4x plus 4 become? X plus 2 squared. Plus, same thing for the y values. What would I get there? Y minus 3. Remember, the sign is always going to be the same as your linear term. And it should equal what? 5, -8 plus 13. Okay, so what's the radius in this case? The radius is actually square root of 5, right? Okay. What's the center? -2, 3. Okay. Good. That wasn't so bad, was it? Easy? I'll give you one that's more challenging in the next couple of days. Okay, and this is the last problem, 6A through C, that the other classes got to. It says the diameter of a circle contains the points 5, 5, and -3, -1. So first, write the equation of the circle in standard form. Bless you. So I need 2 things here. I need to know what the center is, and I need to know what the radius is. Okay, so there was one formula that we haven't looked at yet, but I did mention it at the beginning that would be very, very useful to us. Okay, so these points represent the endpoints of the diameter. So what's going to be halfway between them? The midpoint. Okay, the midpoint formula, that's going to be the center. In fact, does anybody remember the midpoint formula? Okay, what do you think, sir? You could do that. Okay, now that would have you find the radius, though. Okay, so you're absolutely right. In order to find the radius, once we have the center, I could find the distance from it to one of the diameter's endpoints, or I could find the distance of the diameter divided by 2. So we have a game plan for the radius, but what was the midpoint formula? What was actually going to help me find the center? Satish, do you remember it? There we go. So somebody was knocking real fast. Let me put this. Hey, come on in, sir. You'll put that in the tray. Okay, so the midpoint formula. Okay, you're going to take the sum of the x's divided by 2, and then the sum of the y's divided by 2, and this was going to give me the center of my circle. Okay. All right. So what I'm going to go ahead and do is start passing back your quizzes, let you guys look over those, but at the same time, go ahead and finish up parts A, B, and C. And then we'll get some folks up here to go ahead and help me with those problems. All right. So let's see. Come on in. Let's see. Alyssa's not here. Ethan. Chance. Alex. Enzo. Eight. Lips. Raphael. Marion. Connor. Steve. Dylan. That's it. Was, and that's it. Okay. Whew. So like I said, a lot of people did really well on that quiz. If you are wanting to retake it, you have until Thursday morning by 8:05. Okay, I'm here every morning if you want to come in, ask some questions before you do so. We'll probably be able to talk about a few questions right as soon as we finish up these problems here. In fact, is anybody done with 6A? Has the equation ready to go? Okay. Dylan, would you be willing to come on up and show us? All right. What's that, sir? Just 6A. Yeah, just 6A. Okay. Okay, so he says the center is at 1, 2. Perfect. Okay, so we're going to find the distance between a diameter's endpoint and the center. So this way he doesn't have to divide by 2. Bless you. So that'd be 4 squared, 3 squared. Okay, so square root of 25 is 5. So it looks like we're going to have x minus 1 squared plus y minus 2 squared equals 25. That's perfect. There we go. Okay. All right. Any questions on what he did? Okay, so who has the equation of the tangent line at -3, -1? Okay. Well, let's see if we can find a volunteer here. 18. I believe that is Jacob. All right. Okay. Okay, so we need to help him out. Where would we start? Okay, so Satish, what do you think? Okay, so we got to find the slope from the center to the point where we want to write the tangent line. So between 1, 2 and -3, -1. All right, so let me go ahead and write this out here. So we want to find the slope between the point 1, 2, the center, and the point on the circle, -3, -1. Someone not? I don't know if I'm hearing things or somebody did. I think someone did. Oh, okay, come on in. Okay, thanks, sir. All right, so Jacob, how would I find the slope between those 2 points? Just like we did on the previous problem. Yes, sir. Now, we can definitely use the point slope, but before we do that, we need to go ahead and figure out what that slope is. So we need the change in y divided by the change in x. So do you want to start with the 2 or the -1? Okay. There you go. 2 minus -1 would become 2 plus 1 over 1 plus 3. There you go. So it looks like the slope is 3/4. But at the point where the line is tangent, we know it's perpendicular to the radius. So what would be the perpendicular slope we need? -4/3. Okay. All right. So see, now you have your slope. Okay. And we have the point of tangency. So we have the y1 and the x1. So all we have to do is just plug in now. Okay. So y plus 1 equals, good, -4/3 times x plus 3. Okay, now we just need to simplify it. Let's distribute that -4/3. So y plus 1 equals -4/3 x minus what? -4. There you go. Very good. And then all I have to do is move one term over, and we have our equation. That's it. Perfect. -4/3 x minus 5. Okay, good. Any questions? Did anybody not get that? Anybody need help? Okay. Well, I think C is just going to have us sketch both of these. I'll go ahead and take care of that. So we had the equation x minus 1 squared plus y minus 2 squared was equal to 25. And we just ended up with y equals -4/3 x minus 5. Okay, so we have the circle with the center at 1, 2. And then we want to go 5 units in every direction. So that would be right there, right there, right there, and then right there. Okay. And then I also know that the point of tangency is going to be -3, -1. So I'm going to go ahead and put that point. And let's see if I can. That's a horrible looking circle, but it gets the job done. Okay. So there's my circle. And I know that it intersects the circle of my line at -3, -1, and it should be crossing at -5. Okay, so that should be the line tangent to the circle at -3, -1. Okay, and there we go. Questions? Easy, right? Okay. Good, 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 good. Now remember, none of this is on the exam. It's just going to be parabolas and the binomial theorem. All right, so what I'm going to do, let me shut this down very quickly.